Quantum physics. Welcome, ladies and gentlemen, mystery seekers, musers, conspiracy theorists, interdimensional philosophers, seekers of truth, and last, but certainly not least, all of you with confirmation bias. You will find what you're looking for. You're listening to Musings on Mysteries and the Mythical Matrix, family-friendly podcast where we logically speculate on life. The only trigger warning for this episode is a logical conversation where we point out holes in the standard model. So if applying the Socratic method on the scientific method is disturbing to you, turn off the podcast now. Trace, over to you for our fish fact for this episode. Make it something quantum. Just whatever you do, just put the word quantum in front of whatever fish fact it is.
Okay.
We'll make it quantum.
I can do that. So, in theme of recording this during Shark Week still, I'm going to try and stick with the theme of sharks for these couple batch episodes we're recording.
Quantum sharks,
sorry. So the the short fin quantum mako shark is the fastest shark in the world. It can go
at quantum speeds.
Yeah, quantumly 43 miles per hour or 70 kilometers per hour for those non-American people.
Give it to me in dishwashers spin cycles per second or something.
I don't know.
I need some atrocious math here. You gave me something once before. I forget what it was, but like we were talking about dinosaurs or something, and you gave me the most random. No, we were talking about that sea anomaly, and you measured it in terms of 2 Texas.
Yes, 2 Texases.
What's this in relation to Texas? How long would it take it to travel across? In terms of quantum physics, of course.
Hold on, wait. It would take.
Here, I'll say something smart while you're doing this here. So, the reason we're saying quantum in front of everything is because I'm going to be talking a lot about quantum physics here, and it's took a while for me to wrap my mind around, but I finally got it. And the main reason that I finally was able to understand quantum physics is I just realized quantum was just a fancy word they threw in front. It's basically just physics. It's just a little bit more abstract of physics. So a lot of times when you hear the word quantum in front of stuff, as I said in the last episode, you can drop the word quantum and it'll be all right. Trace has the information, so I will stop rambling.
So it would take almost 18 hours for a short fin mako to go full speed across Texas.
I'm so proud of you. You did that math on the fly. That's amazing.
Mm-hmm. I just had to look up how big Texas was because I forgot.
Fair enough. All right. Well, thank you for putting that in quantum terms for this quantum episode on quantum physics. But no, I am actually serious here. The quote from Ant-Man, do you guys just put the word quantum in front of everything? Is it Ant-Man 2? Ant-Man 2, yeah. That quote is accurate. So yeah. I'm going to jump in here. One thing I'm going to lay out from basic physics here is Newton's first law. An object at rest tends to stay at rest until acted on by an outside force, also known as the conservation of energy. And this principle is going to play into things we're going to talk about later in quantum physics. But I'm going to start here by reading a quote from Werner Heisenberg. He is one of the founding fathers of quantum physics. There is, in fact, a Heisenberg principle of uncertainty we're going to talk about very soon. So he attributed a lot to the quantum field of quantum science.
This isn't the Heisenberg from Breaking Bad, by the way.
I didn't know there was a Heisenberg. Hey, if anyone's listening and you're thinking about emailing into the show, count how many times we say quantum in this episode and send it to us. I'm curious. Anyway, that being said, quote from Werner Heisenberg, "The first gulp of the glass of natural science will make you an atheist, but at the bottom of the glass, God is waiting for you." I just thought that was a very interesting quote, and that's very fitting to the conversation I told about a couple episodes back with that one person on TikTok that said that no one that's Christian is intelligent. No one in the intelligent fields believes in a God. Everyone that's in the intelligent fields is an atheist. That is very staunchly disproved. Werner Heisenberg obviously took his faith seriously at least one portion of his life, and he was a Lutheran. Newton was also a Christian, I believe, and I'm sure there were a number of other scientists. So you don't have to be an evolutionist or an atheist to be a good scientist. Being good at science transcends whatever your individual belief systems are, but those belief systems can attribute to confirmation bias.
Science is for everyone.
It's like that one meme where this guy's looking through a book, and he's like, everyone seeks confirmation bias. Ha! I knew it! Then he just stares off into oblivion, realizing that he's been seeking his own confirmation bias. All right. So Schrodinger's cat, this is the first principle of quantum physics here. So Schrodinger's cat is a principal trace, and the idea behind it is that it relates to quantum principles. If I put a cat in a box and I hand you the box, is the cat dead or alive?
You don't know until you open the box.
So yes, you don't know until you open the box. But if you're thinking in terms of quantum physics, this is going to be mind-bending here. And this isn't me making stuff up. This is indeed quantum physics for our listeners that aren't familiar. The cat is both until you look.
That's it.
Yes. So the cat is both dead and alive until you open the box and look. And then it chooses one or the other. And that is very similar to things like atoms, where the double slit experiment that they did, where when they measured the atoms, I think it was like maybe even light that I think it was light.
I think it was light.
Yeah, it was light that they were shooting through. It chose between either being a wave or a particle, depending on how it was being measured and the observation. But when it wasn't being measured or observed, it behaved as both.
Yeah, that's just wild to me.
Yeah, I know. So this is definitely mind-bending physics here. But this can still be grasped by the layman, I think. And that's what I'm trying to do here is I had to read through a crap ton of stuff to try to figure out all these different quantum models, because I want to talk about quantum creation models. But before I do that, I have to explain quantum physics. Otherwise, it's not going to make sense to our listeners here. So, all right, let's keep going here. So this kind of plays a little bit into a similar principle of quantum physics, the Heisenberg principle of uncertainty. So this is where Werner Heisenberg comes in. You can only measure position or speed / momentum, not both at the same time when you're measuring components in the quantum realm. And this is just understood as a general principle of quantum physics. So the way that the quantum physics works is you can only do measurements of one thing at a time. Things happen on that microscopic atomic level very, very quickly. And we're going to keep expounding upon this and building off of this idea. But do you understand that general... I don't expect you to understand it perfectly, Trace, but do you understand that general premise and at least the statement of what I said?
I think so.
Okay. So we're going to shift gears here. Quantum computers, how quantum computers work, because I think that applying this to concrete methodology is going to help our listeners grasp this a little bit more. So quantum computers operate off of the Schrodinger's cat principle. So the way it's set up is it's a bunch of logic gates where the bits of data are stored as Schrodinger's cat would be stored, where it is normal computers work off of like zeros and ones, but in quantum computers, it's a 0 and a 1 until it's observed. And there are certain ways you can set up logic gates in these computers to make the probability more likely that it's going to be either a 0 or a 1 when observed. Does that make sense? Like it's basically, this is a little bit of an overcharacterization because this isn't exactly true, but to really boil it down simply, quantum physics is a field of uncertainty, but you can predict what actions are going to be chosen to a degree based off of the behaviors or the way you're observing or measuring. Does that make sense?
You kind of lost me halfway there.
Okay, so think about Schrodinger's cat, right? So everything think about the quantum realm just being this blank, empty space, okay? And it's got all these atoms floating around in it.
Yeah.
They function under the principle of Schrodinger's cat, right? So they are both dead and alive. They are both particles and waves until observed. But then there are certain factors, and these I'm not familiar with, but when it comes to quantum computing, there are certain ways I can look at these atoms that will determine if they choose to be, well, not if they choose, but it will determine if they default to be an atom or a wave, or a particle or a wave, excuse me. Does that make sense?
I'm going to be honest, not really.
Okay. So I think I'm going to try to, tell you what, we'll take a short ad break here. We'll take an ad break a little early. I'll think about how to explain this a little bit differently, and we'll come at this again. How's that sound?
Sure.
All right. Be right back. All right, ladies and gentlemen, mystery seekers, musers, we are back attempting to explain quantum physics to you.
Failing.
Well, all right. So
I feel like there's no good way to explain quantum physics.
yeah, so we left off, Trace was a little bit confused about the logic gates in quantum computers. So I'm going to try to explain this again here. And I don't have concrete examples because quantum physics was not my field of study. My field of study was in math and psychology, but it gives me a bare bones enough of an understanding to have done my own research and have a little bit of familiarity with the field and familiarity with all the weird symbols and the Greek symbols that you see in math. So think about it this way, Trace. We've done enough experiments on these quantum bits of data that we know that if we observe it one way versus another way, or we choose to interact with it one way versus another way, that the probability that it's going to be a 0 or a 1 is incredibly high. Basically, we can kind of trick it in a sense, or force it in a sense, by the way we are choosing to measure it and interact with it to make it go either one way or the other.
Okay.
So so here's a more concrete example. Like if you're trying to leave and I stand in the door and I stand to the left side of the door, you're probably going to go to the right side of the door, right?
Yeah.
Likewise, if I choose to stand on the right side of the door, you're going to go through the left side of the door.
Yeah.
You could still try to force your way through, but by me just standing there, I've increased the probability exponentially that you're going to choose one action over another.
Okay.
Right. So that it's kind of similar to that. So that's how we interact with things on the quantum computer level. So now I'm going to talk about this other concept. I apologize if this is going a little fast for everyone. Please email in if you got questions. I'd be happy to go back and talk about this a little bit more. I was really geeking out over this subject. Quantum physics is pretty cool. But we're going to talk about quantum fabric of reality. So it's not as confusing as it sounds. The quantum fabric of reality is basically just gravity fields, electromagnetic fields, Higgs fields, all sorts of different components of physics that we know exist, and it's all just kind of lumped in and described as being the quantum fabric of reality. So the way that I was kind of able to conceptualize this is that quantum fields is like the overall sheet of the universe. And that gravitational fields, electromagnetic fields, all these other fields are little different subplanes or threads that weave into this quantum blanket of reality that we live in. And so even if you go to the most light void, empty vacuum space of the universe, of the known or unknown universe, as long as you're still in reality, you will still have these fields interacting with you in some way or another. There are still going to be fluctuations of these fields. So even in a vacuum, these fields exist, although very, very small and very, very difficult to measure, that they are often negligible. Does that make sense?
Yes.
All right, cool. All right, so I'm going to try to...
See, even you're getting confused by your own notes.
It is confusing. I'm going to take a break here. I'm going to talk about an article, and then I think I'll need to do another ad break to kind of regroup myself here because it's definitely a bit abstract. So there's this really cool article I was nerding about a couple episodes back, and it's pretty stinking cool. So the way that they set up this experiment is they fed the Fibonacci sequence into the rhythmic pattern of a laser, and they shot it at, I believe, these quantum bits, these qubits that are used in quantum computing. And they are attempting to preserve their state of uncertainty. And they were able to do so for several seconds, which might not sound like much, but in terms of quantum physics, that's a huge deal. That's a really big deal. And them being able to do so suggests that the mathematical model they used to set up this experiment actually suggests that they discovered or were able to use components of a second dimension to time, which is kind of mind-blowing because, you think about it, maybe they're kind of warping how the quantum bits perceive time and are able to interact with time and slow time down for them in a sense. So that the quantum bits, and this is just kind of me theorizing what a second dimension to time means. They haven't absolutely proved this, but it's just what's indicated by the mathematical model that was used in like the math that they used to set up this experiment. And so what that means to me is that they probably did something where they altered the perception of time for these quantum bits and made them behave in a way that from our observation of time just isn't normal. But then this indicates there could be extra dimensions to time, which indicates that there still are dimensions to reality we have not yet discovered. And that is a huge deal. Huge. Anything you want to add to that?
I was confused by this when you first came to me with it. So I just want to put out there my definition of it. So basically, they put a math sequence in that was assuming the second dimension, and it came out correct. So it may or may not be proving this second dimension to time. What that means, who knows? Yeah,
so it's not a proof. It's just, hey, there could be other explanations for why this mathematical model works. But adding a second dimension is how they're able to ultimately achieve this effect. Yes. So that's a great summary there, Trace. That being said, we're going to talk about virtual particles in a minute here, but I got to gather my thoughts on those before we kick off here. So we're going to do a short ad break. All right, ladies and gentlemen, quantum physics enthusiasts.
I thought you were going to say quantum, ladies and gentlemen.
No, I will, though, however, say quantum mystery seekers, quantum users, quantum conspiracy theorists, and then interdimensional philosophers. Philosophers are already abstract enough. They don't need to get the quantum thrown in front of it. That would just make the universe implode, and we are not trying to do that on this show. We are just trying to implode your minds.
Your quantum minds.
Your quantum minds. We're having too much fun with this. We're probably annoying a lot of the listeners right now. All right, so virtual particles. Virtual particles are particles that just kind of pop up in reality. They just kind of pop up for a split second and then they disappear. So even a vacuum, even an absolute vacuum in outer space is not a true vacuum because there are these fields interacting with reality. And so these virtual particles are just like quantum particles that'll flicker up real quick and then they'll disappear. But they are so short and they're so small that we can't really get a good measurement on them with anything that we have available at this point to us from a science perspective.
I feel like I recognize this kind of thing from something. I can't remember what it's called, but I think I might recognize this.
Yeah, so you might recognize it under the name of the Casimir effect. And what they did is they had like two plates that were really close together in like a vacuum. And they found that there was still an attraction between those two plates, even though they weren't like magnetized or anything. And that's kind of how one of the tests I think they did to help prove the virtual particles concept. So the question then becomes, if you have particles that just flare up in a vacuum and will kind of do their own thing for a little bit, is this breaking Newton's law? What do you think, Trace?
I can't remember what Newton's law is, to be honest.
The one I read at the beginning, conservation of energy.
I don't know.
So on a surface level, it might seem like these virtual particles are just popping up out of nowhere and generating energy out of nowhere and then disappearing. That really isn't what's happening here. What's really happening is it's just fluctuations down the fabric of this quantum field, if you will. So there's fluctuations that occur on one end, and that kind of triggers fluctuations in other ends that can happen to be in a vacuum that triggers these virtual particles. So it's not just stuff spontaneously appearing out of nowhere. It's just kind of natural fluctuation and almost waves, if you will, in these fields that happen so quick it's really hard for us to measure. And then you also have Another component, such as quantum entanglement. So this is really interesting, is where you have two particles interact with each other in such a way that they become bound together, but you're able to physically separate them. But then if I were to touch one, the other one, even if it's miles away, would still feel that same effect instantaneously. And that's known as quantum entanglement. So you also have that component to virtual particles as well, where that wouldn't be the only explanation. It would just, the virtual particles primary explanation is just fluctuations in the field, if you really want to simplify it down. But then you have other components like the one I just described, where you have quantum entanglement. Okay. So no, I've had discussions with people on this before. It's not, when you really you have to really study it to figure out what's going on here. It's not a simple answer. But to boil it down to the answer I was able to come to after my research is no, it's not breaking Newton's law that these virtual particles exist, because they're just kind of little blips on the radar, little minuscule fluctuations, and then it just goes away. Anything you want to interject, Trace? Because I see you kind of spacing out a little bit.
I was trying to find what I was thinking of, but I can't find it. But I did find something about.
If you could look at the mic when you're talking, good sir, because they can't hear you. I can hear you.
Well, sucks for them, I guess. So I couldn't find what I was looking for, but I did find, in an article from 2017. Physicists just achieved quantum teleportation underwater for the first time.
I haven't looked at that at all, so I'm going to have zero comments on that, but that is very cool.
I'm not going to understand any of this, I don't think, but basically, they successfully sent information between entangled particles through seawater.
Oh,
so it's the first time this has been achieved under
okay, yeah,
water.
So okay, I actually do understand that then. So basically they entangled two quantum particles and were able to kind of like mess with one particle and like maybe Morse code or something like that, and the other particle was able to pick it up and they were able to read it underwater. Yeah. That's basically what that's saying.
Yeah,
I don't know the exact methodology, but that would just be a way to simply transmit information via a particle.
Yeah, there's a whole article here, so I can get into that if you want me to.
Don't need to. I feel like that goes outside the scope of our general quantum physics familiarization. Okay. But if you want to send us a quantum email and ask Trace to delve into that article, maybe we will explore that quantum component in a future episode.
Yeah, just send it straight to my brain, if you could.
Yeah, you just got to quantumly entangle it with Trace's brain, and he'll just know, and he'll be like, midway through recording here, he'll just be like, you know what, we need to talk about that. Yeah. We need to talk about that article. All right, so now that we've laid down this groundwork of what quantum physics is, and some of the laws that apply in quantum physics, I'm going to shift gears. So this is where it's going to get a little bit easier. If you feel like you've understood everything at this point, Trace?
More or less.
Okay.
As much as someone can.
So if you don't feel like you've understood stuff at this point, that would be a good time to go back and re-listen to the episode is right here, because we're about to shift gears into quantum creation models, or quantum exogenesis, I guess is probably the right term, exogenesis models for the universe starting to exist. So if you don't have a good understanding of everything we just talked about, or at least a bare bones understanding, this would be a good time to stop, go back, kind of reattack it, reassess it, maybe go look at some resources outside of the podcast. But if you feel good enough, we're going to keep rolling. All right. So there are 5 key models that are believed by scientists, or at least proposed by scientists, to be models for the creation of the universe. So scientists have taken everything that we've just examined here, Trace, the whole quantum principles, obviously on much deeper levels, and they've taken this and they've applied it to the origins of the universe. And they've tried to use these principles we're observing in quantum physics to suggest how the universe came into existence, obviously without God. So the first model is quantum fluctuation model. Basically, a summary of this model is it suggests that a quantum fluctuation occurred in a primordial vacuum. So that there was a vacuum before time or the universe existed, but that there was still those quantum fields of reality, and that there was a little fluctuation in there, and somehow from that quantum fluctuation of the virtual particles, everything triggered into existence. Next one, quantum tunneling model. So the universe emerged from a quantum tunneling via a quantum vacuum state. So it's kind of the same thing, it's just involving maybe a little bit more of the quantum entanglement idea. Third, we have Vilenkin's quantum creation from nothing. quantum fluctuations created the universe, and ultimately all the energy balances out to zero, thus initiating the Big Bang without violating conservation of energy laws. Negative energy being the energy used to separate two objects, not proven, but it's used in theoretical physics pretty regularly. So this one here kind of assumes that we're a complex chemistry equation, if you will. So for those of you that are familiar with chemistry, I know you're going to be familiar with chemistry, Trey's taking all your biology courses because that's definitely a component. Think about like, you know, how you have the reactions balance out. It's kind of like we're in the middle of two different reaction states, if that makes sense. So this kind of proposes the idea. This might be an oversimplification. It might not literally be this, but I'm going to say it to try to explain it to the listeners, of like negative energy and versus positive energy, negative matter versus positive matter, and that everything in the universe ultimately balances out to zero. And if everything came into contact, then everything would cease to exist. That's kind of the general idea of this. There's a bit more nuances to it from my memory, but that's the gist of it. Any questions so far? Because those are the three hardest ones.
Is that like is the negative matter, is that like dark matter?
Yeah, kind of something similar to that. I'm overgeneralizing here. I think that I might be making some slightly incorrect statements here, but I'm not going to worry about it for simplicity's sake. Just take what I'm saying for now. There might be nuanced corrections that those that are physics majors or have their maybe like a master's or doctorate in physics, they're hearing this and they're like, no, it's not technically dark matter, it's something else. But for the intents and purposes of this podcast and for the confines of the broad audience, yes, that's a good understanding to have. Tracking so far?
I think so.
All right. So next one is the Hartle-Hawking no boundary principle. So this comes from Stephen Hawking, actually. This was his theory that he worked with another scientist. So he proposes a gradual, for lack of a better word, I'll say creation, but there's no inference of a creator. It's just more of the universe coming into existence. So a gradual existence of the universe, no initial creation, quote unquote, point or Big Bang, just everything kind of slowly progressed into what it is. So, I mean, it's pretty similar to the Big Bang. If you look at it, it's just scaling time differently based off of...
So kind of like an evolution, but for the universe itself.
Yes, exactly. Then the final one is connected to string theory and brane cosmology, B-R-A-N-E, not B-R-A-I-N, cosmology. It's a multiverse theory, so that there are, infinite number of other universes tied in, and that something fluctuating in one of those universes triggered quantum fluctuations in our universe via quantum tunneling or some other feature, and that our universe then sprung into existence from that. So then obviously you're faced with the question of you're just kicking the can down the road. Okay, so how do those universes get created? Quantum tunneling. How do those universes get created? Quantum tunneling. How do those universes get created? See where I'm going?
So it's like it's kind of like a time travel thing, maybe. So like, let's say if I threw this bottle cap on the ground, somehow that would then kind of like, let's say there's a bottom line, like a bottom string per se. So if I threw this on the ground right now, it would cause some kind of fluctuation that would then bounce and hit another string, and then that string being hit would create our universe, and then it would kind of like loop back around.
Yeah, sure. It could be something along those lines. It's so abstract, but yes, that there's something that we do where maybe there's a quantum particle entangled with that bottle cap, and that entangled quantum particle bumps into a quantum entangled particle that's on the floor and causes two particles to interact in such a way with each other that they trigger a universe in a different reality. But again, this is highly theoretical. There's been
quantum butterfly effect.
It's a quantum multiverse theory that involves the butterfly as well. So, butterfly effect. But yes. All right. We're going to take an ad break here, not because I need to collect my thoughts, but because we are at about half an hour.
He's lying.
You're a cheetah. All right. We are back, ladies and gentlemen, mystery seekers, musers, and I heard Trace playing a video on his phone as we were coming back, so hopefully that didn't bleed through, but I'm going to draw extra attention to it. So if you did, write an email
My mom sent me something.
Transcend the quantum entanglement of time. And send us an email so I can yell at Trace for it. And you can participate in this very conversation we're having. All right. So I have one final theory. As I was studying all of this, I have my own theory on a way to look at the universe from an atheistic perspective. And so I'm going to throw it out there because why not, right? It's all about speculative reasoning. I believe I'm a Christian. I believe that there was a God that created the universe, but I'm able to entertain other ideas as well. And so my idea was that the universe itself is a set of virtual particles on a much larger quantum field and has existed for a short time in that quantum field, milliseconds. But to us, because of these extra dimensions of time, to us, it's thousands or even millions of years.
So every quantum interaction that we have is just a mini universe.
Yeah, exactly. It could very well be. That was my theory. I'm not saying there's any credence to it. I haven't done zero research for it. I saw no theories out there like this.
That feels very like Men in Black with the cat collar with the universe in it.
I haven't seen any of the Men in Blacks.
Oh my gosh.
I'm going to get yelled at by Trace after this episode, and then I'm going to have to beat him up because he's going to try to beat me up, and he's going to lose because he won't have a sword.
Got me there, I guess.
I transcended quantum time to predict your outcomes in that multiverse, and I've observed 4,617,852 encounters, and you only win one.
Is that the actual number from
I have
Avengers?
no clue.
Okay. So I said, like, if you just memorize the exact number from Avengers Endgame.
I do have pi memorized out to a pretty far distance.
My sister had it memorized to like 160 something.
Okay,
68.
I'm not that much of a nerd. No offense to your sister.
No, she also carries around a little book of like a little math book. So she's a nerd.
That's fair. All right, she's gonna make more money than you someday, dude. You shouldn't make fun of her.
Probably.
Yeah, definitely. All right. So, looking at all these theories, though, Trace, they all have one core principle, and it's namely that the quantum field, our whole fabric of reality, all of these other fields existed primordially outside of the universe, so that these fields that we're observing then transcended the universe. Thoughts on that? So when we're so quantum fields. So let's boil it down. So the quantum fields is things like gravitational fields, electromagnetic fields, all of this. All of these theories rely on the idea that these fields existed before the universe, primordially, before the Big Bang, creation, whatever you want to attribute it to.
Okay.
All of these theories are built off of that. And that's a problem if you're looking to talk about this exogenesis, this creation from nothing. Because they're very loose theories based off of observations of quantum particles in a vacuum within the limits of our testing already in our observable universe. We have no clue what the quantum particles or things in the quantum realm, in these quantum fields, would do or look like under the pressure and different constraints of pre-matter or primordial universe conditions. Or if these quantum fields would even exist at all. They might not have existed primordially, especially looking from an atheistic perspective. So these are all acceptable theories, but they're just that, theories. And there's a lot of big problems in these theories as I'm starting to lay out for you. And this is the issue I start to have when you look at the standard model, is because oftentimes these theories, these explanations, they'll sound really good because they're professed by scientists, but when you really dig into it, there's a lot of errors, inconsistencies, assumptions made in here. Because you're assuming when you're observing virtual particles from the Casimir effect that those virtual particles, one, would even have existed primordially before the universe, and that two, they would interact this in any kind of similar way, and that three, they would interact even in a greater way to then generate and kickstart everything that existed in the universe now.
I think I get it.
Trace is yawning. I'm putting him to sleep. We're winding this down, Trace. This is actually we might be done in under an hour unless you have some interjections at the end here.
No, this is definitely a more you episode. I think
this is definitely more of a snoozer for you.
Yeah.
Well, we're going to shift into more of an argument for a creator in a couple minutes here, which will give us a little bit more of a groundwork for having Harrison Smith back on for the next episode. But for now, we're going to focus on these virtual particles. Let me skim through my notes here real quick. Try to say something smart.
Ooh. Gosh.
All right, I'll save you. All right, so virtual particles only exist for a short time. This is from what we've measured in quantum physics. We know this. This isn't an assumption. So why would this rule change in the absence of any matter or items that would affect the quantum field, such as electromagnetic field or heavy gravitational fields, anything like that? It defies everything that we're observing in the hopes of things being different in different circumstances that we're never going to be able to really test or recreate, because then we would have to step outside of the universe to test and recreate these things. So it's just as likely that if the quantum fields even did exist before the universe, that the interactions would still be minimal or negligible. That's just as likely, and probably even more likely from the laws of physics that we know, from Newton's first law especially, since we know that these virtual particles don't violate Newton's first law. So, I mean, to be scientifically consistent from a secular perspective, it's your duty for anyone interested in these fields to explore the truth in science, to consider all possible alternatives. Because if this is the best explanation that we've got with our modern science, this isn't an answer. This is an unknown. And if you're comfortable with that, then okay, fair enough. You have enough faith in these scientists and in the scientific method, then props to you. But this is a theory. This is a loose model. There is no concrete answers here in any way, shape, or form. This is not traditional science. This is, in fact, outside of the bounds of science, because we can never test, recreate, or predict anything that's going to absolutely confirm how virtual particles or quantum tunneling would function primordially.
Well, it's outside the bounds of science right now. Doesn't mean we might crack it later on.
But we have to step outside of the universe then, or at least our reality right now. So we would have to unlock time travel, or we'd have to be able to travel to another dimension to where the rules of our reality are no longer impacted to be able to test things primordially. We would need to get rid of the universe and everything in it except for the quantum fields. And then we would also need to answer whether or not the quantum fields were even around. Does that make sense?
Yeah.
So I'm just saying that there are, yes, maybe in 1,000, 2,000 years, we may have technology that'll let us get close. But at that point, we're going to have absolute answers, because we'll be able to, I think we'll be able to very clearly interact with spiritual if we have that kind of technology to transcend, or the spiritual just won't be there.
Well, I feel like that might be part of the argument there, is that like a lot of science is just that. It's just unknown. At least as of right now. I mean, you look in the past century about how much science has just changed. And we're increasing our scientific knowledge at an exponential rate right now. So I feel like it's not completely out of the question to say that, oh, we might solve this at some point, but for right now, it's completely unknown. We have no idea. They're all just theories and conjecture.
We'd have to have a way to measure how quantum fields interact, not just in a vacuum, but that interact. Well, one, we have to have a way to answer and measure if quantum fields were even around at the beginning, like before the universe existed.
Okay.
And then two, we then have to step outside of the whole universe if the quantum fields did exist, to then see what would they do when put under certain creations. And then that in of itself brings up ethical issues, because then if you're trying to test if you could create a universe from primordial quantum fields before the universe existed, you might trigger the whole causality of another universe, and who's to say that's not an antimatter universe that obliterates the current universe? And so then you have tons and tons and tons of constraints. So there are so many factors where we would have to literally be able to travel interdimensionally to be able to step outside of our reality, which we don't even know, especially from a scientific, I'm talking more from a science perspective than a Christian perspective, but from a science perspective, we don't even know if that's possible to step outside of our reality to the point to be outside and in between our universe and any other universe. And then we have to be able to have the answers of, at the origins of time, was there a quantum field that existed before time? So that's my point here, is that maybe at some point we might be able to have technology to test some of this stuff.
Yeah.
But we're never going to be able to test all of it, because we can never go back to that original origins of the universe and then before.
Now, what if
Oh boy.
we can't step outside of our existing reality at the moment? What if, like, the spiritual realm, whenever we enter into that's would technically, well, possibly be entering a different dimension or realm of reality. So maybe then we could test it out and know.
So this is sounding like an Interstellar explanation here, which I'm 100% open to.
Mm-hmm.
You know, where you've seen Interstellar, yes?
I love that movie. Yeah.
Okay, good. Glad to hear it. All right. But yeah, so for those of you that aren't familiar, I guess I can spoil it. It's been like a good decade or more since it's been out.
It's been out for a good bit. If
you want to explain it, since you love the movie, I have only seen it a couple times.
Yeah, I'm a huge movie nerd. If you haven't seen the movie Interstellar, stop listening to this right now and go watch the movie. It's a great movie. It has what is a lot of scientists say is the most accurate black hole representation. Besides that, it's just a really good movie. They
actually got the imaging of a black hole right before we had even fully managed to image it with the new telescope we sent out. But yeah, I feel like if you've been able to bear through this whole episode, you'll love Interstellar. I feel like anyone that's been able to sit this far into this episode has watched Interstellar. But if you haven't, stop listening. Go watch it. Spoilers coming. You've been warned. Go ahead, Trace.
So,
just kind of summarize the plot for us in 30 seconds, a minute, however long it takes.
So basically, they get sent through a black hole is really what happens, and he kind of enters this fourth dimension where then he can kind of travel throughout time, like all of time and every reality kind of exists at once. So he kind of goes through this infinite reality thing of this one moment to interact with stuff, or not one moment, just like one place in time where he can interact throughout time to influence stuff in this. So it's basically time travel through another dimension.
It's basically entering another dimension of time, almost, in a sense, where he's able to kind of interact across time in like a room, but it gets misidentified as a ghost in the movie, which is always very interesting. I showed my wife that movie, and she was like kind of a little confused at first, but she was like loving it by like halfway through. So
I did hear she wasn't I can't remember her name. She wasn't a medium. She was I can't remember, but basically like she could see into the spiritual world supposedly, and the way she explained it is that it's just another kind of realm of existence. So like not really a heaven or a hell, not really a purgatory kind of per se, but just another spiritual realm, and through this you could do all kinds of stuff. I can't remember her exact things, but I think that'd be fun to go into at a later date and see if there's any
well, there's like whole guides to this in terms of like teachings of astral projection, and I'm sure Bill Rudge will be able to shed some light on all of that for us, where there's actual like guides from people that have been doing astral projection for a long time as to what the spiritual realm looks like. And even depending on how you read the Book of Enoch actually debatably includes travel through the spiritual. Debatably, depending on how you want to read it. And so when we get to that, that'll be an interesting read, I think. So it's like a pseudo Bible book, kind of from the way we've laid it out. We've been referencing it a lot. I feel like we really need to get to that sooner rather than later. So.
Yeah. There's a lot we need to get to sooner rather than later, but
yeah,
a lot of stuff to cover.
Yeah. So here's the ultimate issue, Trace, is that if these quantum forces existed before the universe, then the laws that govern these forces probably existed before the universe. We have no reason to believe not. So if these quantum fields existed, then Newton's first law would have also existed, because we know virtual particles don't violate it. And so it just is incredibly unlikely, and to me it just feels like seeking out confirmation bias from these scientists to try to offer maybe they don't even know that they have confirmation bias, but they're trying to offer a super abstract, complex explanation off of a science that we're still discovering components to, and that we don't fully have the answers to how it all works, and we don't really understand it, to the point they're scratching the bottom of the barrel to try to find anything to avoid looking at a creator. That's the way I see this from my research and looking at these explanations. I feel like you probably are going to see it different, and that's fine. But what interjections do you have?
I don't think I have any. That was a lot of words.
All right, you got excited when I brought up Interstellar, and then you started spacing back out again. So, I mean, I don't know what else I was expecting, honestly, but that's fair. All right.
You mentioned a movie I like, and I'm zoned in.
Yep. All right, so we're going to shift to the final section of this episode here. Are we due for another ad break? We're due for another ad break. We're going to do an ad break. And we're back, ladies and gentlemen, Mr. Seekers, quantum users, quantum conspiracy theorists with your quantum tinfoil hats.
How long is it going to take you to come up with all these quantum things?
I don't know. I might keep going back to it, transcending the quantum boundaries of time.
Okay.
But anyway, so moving on here, there is a bit of an argument for a creator here, I think, that I've begun to touch on a little. And I also want to present the idea of quantum field pre-creation might actually be biblical. As we studied in Genesis 1-2, it talks about how there was waters before God started creating, before time even, that God was hovering over the face of the waters. And then God said, "Let there be light." And then there was evening and morning the first day. So, I mean, quantum fields transcending time might actually be a biblical perspective. So it's interesting to take these ideas and to circle them back to myth and to apply science to myth and see, not that, from our definition of myth in the previous episode, I'm not saying that Christianity is fake because I am a Christian, but from the perspective of a religious story, circling it back to a religious story and examining it, I think that there's something there. But I mean, then again, you do have time being created on the first day. There was no time before that. And so would these fields have been able to have existed without time? And that's a whole nother question right there. And I don't have an answer to that. And it doesn't look like you do either. So
I don't have any quantum answers.
So despite all of the efforts here by scientists, you still need a Newton's first law still exists and applies as far as we know. We've never, even at the quantum level we're able to measure, we have no proof saying that doesn't exist. You're still requiring an infinite mover, or at least some viable logical solution that would equate to that, whether you want to attribute that to a god or whether you want to attribute that to a some kind of infinite force like in Star Wars, however you want to equate that. But they're logically, from everything we're able to deduce now with science and what we've laid out in the last 2 episodes about science, I think that you are faced with the fact that, at least with the information we have right now, we need to introduce some kind of creative force, or at the very least, we have to be willing to admit to ourselves, you know what, there are a lot of gaps here, and I just need to have faith in this methodology and that we will find these answers. And if that's you, then that's your choice, and that's fine. I'm definitely not comfortable with that. I don't think Trace is comfortable with that, but we will certainly respect whatever beliefs you want to hold. But I think, in my mind, the point of this podcast is we're using all of the tools in our toolbox to analyze what happened and to discover things about the universe. We're using science, we're using math, we're using history with our comparative mythology. We're applying the scientific method where we can. We're stretching the limits of it, but we're also being honest and admitting when it can't be stretched. And questions, when you're assuming things in a mathematical equation, you're going to get weird and wrong outputs. And I think that's the same thing in the scientific method. We're applying logic. We're using everything we can to seek the truth. And that's the ultimate intent of the podcast here. And so I'm going to finish out with one last point. But most cultures in the world have a creation account or a beginning story for man and the universe and everything else in the universe. And more or less, the stories tend to have a similar theme or trend in them. Comparative myth does have something to offer this puzzle, I think. I think that just relying solely on science, I think that is a mistake. I think that comparative myth, while you need to understand that not all myth is going to be absolute truth, I think that looking for that common thread of something that all of these people believe has something to offer. But it needs filtered, and that's what we're here to do on the show. And suggest evidence that we've missed. So I'm not doing the bandwagon fallacy, because I got accused of that recently on TikTok, of doing the bandwagon fallacy by saying that all these other cultures believe in a God, so is it possible we've missed something? I'm not saying, oh, all these other cultures throughout time have believed in God, therefore God is real. That's like saying, oh, everyone else believes in a pink unicorn that can surf rainbows, so therefore pink rainbows are real. That's the bandwagon fallacy. No, that's not what I'm saying here at all. What I'm saying is the fact that so many people have believed a similar trend throughout time indicates that there likely is evidence that we're missing. And then you also have to factor in the trustworthiness account too. So like we discussed in one of our 2 previous science episodes, I forget which one, but where we were talking about the genetic fallacy, where I'm not going to believe something because Trace says it, but Trace is demonstrated to be a trustworthy individual, so I'm going to be more inclined to believe it just because of his character and what I know him to be, and that would not be the genetic fallacy. So likewise, as you have these oral traditions being passed down of what happened, or written traditions being passed down that are turned into myth, these people are trusting their ancestors to tell them the truth, at least in some capacity or another. And so yes, it might get convoluted and bleed together, but there's trust in these accounts. And I think that that's worth considering. If they think it's so worth making up, or, well, not making up's the wrong word. If they think it's so worth telling the story, I think we should at least hear the story. If it was so worth passing down through hundreds, thousands, even billions of years, depending on your perspective, it's worth hearing just to see what it has to say. Maybe it has insights to offer that we haven't thought of. But in conclusion here, I think we're faced with the reality. It's my opinion, my personal opinion. We're faced with the reality that there has to be some infinite mover beyond the universe. There has to be some instigating process that we're just not familiar with. It has to be something outside of our reality. But then that starts to sound familiar, doesn't it, Trace, to our Genesis analysis, and how we see God described in Genesis. And that, for me, was the ultimate finishing punch for me coming back to Christianity when I was struggling with my faith, is looking at, okay, there needs to be something outside of this universe to create. An infinite mover has to move. And for me, that was my explanation to say, you know what? Christianity has the best explanation. You see that outlined from the beginning in Genesis 1:1. But to each their own again. I'm not trying to preach. I'm not trying to force anyone to believe anything. I'm going to respect whatever beliefs you have. What I won't respect, though, is people like Billy Carson that want to twist myth and use it to promote their own agenda. That I have a huge issue with. But believe as you please. And I guess we'll leave it at that. Do you have any final thoughts for us, Trace?
Yeah, no. I would agree with everything you said. I think, at least in our own conclusions, Christianity makes the most sense. But, to each their own. Yeah,
and you've got to figure out, if you don't think Christianity makes sense, you shouldn't believe it. Whatever you believe has to make sense to you. And you have to come to terms with, I have questions I can't answer no matter where I go, whether it's atheism, evolution, whether it's Christianity, whether it's Islam, Hinduism, Buddhism, Zoroastrianism, astrology, astronomy, whatever you want to believe in, you're going to have questions that your belief system just isn't able to answer. And that's okay. But you need to decide if you're okay with that or if you're not okay with that. And that's where faith comes in. And you have to have faith in some capacity, to some degree, no matter what you believe. That being said, Trace, give us a creature fact. Let's close out.
So I think this creature warrants an entire, maybe not an entire episode, but I think it deserves its own story being told. But I'm just gonna give a little.
You've been saying that about a lot of creatures recently, so we just need to start doing cryptid episodes.
I know we do. I am 100%
Get on
prepared.
That.
All right. Well, you got the whole plan here. So if they fit in somewhere as a little filler episode, I will gladly do it. But the Dover Demon, it's just a little goblin kind of creature that was spotted in 1977, where some teenagers were driving and they spotted this thing sitting on top of a wall. What are you doing?
You keep looking away from the mic. I'm trying to subtly tell you to keep your face looking at the mic. Move your notes up if you.
All right. Okay. All right.
You keep going like this and this and this and this. Driving our listeners crazy, I'm sure. Please continue.
So it was spotted. This teenager was driving, and they spotted this alien-like creature sitting on top of a stone wall in Dover, Massachusetts. So it's become kind of a small-town monster. As many of these cryptids are, they're just small-town monsters that are kind of get to become the little local town legend, like the Lakeworth monster of, I think that was last episode. We recorded that. But yeah, it's got a few different sightings, real interesting stories, some possible explanations to it as well. So whenever we get into a cryptid episode, I will be going further into this, but I just want to give a little teaser.
Fair enough. So I will give a notice here. We're probably more than halfway. By the time you're hearing this, we're more than halfway through probably. But Joyce and I will both be gone at various points. So we're not going to be able to do any corrections that are on any issues that pop up in these episodes. So if you heard major mistakes in the last episode or two and you emailed us about it, we're not going to be able to address it until late August. So just so you're aware, as the listeners, we've been batch recording several episodes for you to make sure that we don't miss a beat. And this is the last one we got to do. So I'm excited to, I love podcasting, but I need a break, man. We've been... The
batch records are definitely a struggle.
It's a struggle.
3 days in a row where...
I just want to hell dive, man.
I know, yeah. Video games.
Trace and I regularly hell dive together, yes. All right, well, unless you have any other confessions, concessions, contentions, snide remarks, interjections, anything like that, I'm going to wrap up the show here, and I'm not seeing any expression on your face, so I'm going to take that as a no. So great. We're going to wrap up the show here. If you want to get a hold of us, you can email us at m.quad.musings@gmail.com. You can find us on Instagram and TikTok at m.quad.musings. You can find us on Facebook at Musings on Mysteries in the Mythical Matrix. Just type that in. We'll pop up. Give us a follow or a like. If you're listening on YouTube, Spotify, 'cause I don't think I hit this in the beginning. If you're listening on YouTube or Spotify, please give us a rating, a like, a subscribe, whatever is appropriate to support the podcast. The more support we get from you as the listeners, the more we're able to generate good content and to continue to generate better content. And that is my desire, is to be able to go on more explorations for the listeners and be able to talk about our experiences on said explorations. And you see that get highlighted a little bit in the explorations, Ark Encounter and Serpent Mound episode. But hopefully that's just the beginning. I want to go lots of cool places and take good footage for our listeners to be able to actually feel like they're there and be able to show it to them. Mm-hmm. And then I'd be able to discuss it and kind of talk about our thoughts. Because I've heard this on other podcasts. They'll talk about, nothing compares to really just being there, and you get hit with a whole new wave of thoughts and ideas, inspirations of explanations of things when you go in with an open mind and you actually see some of these places yourself.
Yeah, the thing I really want out of the future growth is feedback. So we can finally know, okay, this is stuff that people want to listen to. So instead of us just constantly bouncing around, kind of wondering, where do we go next? I mean, I know we have like a whole kind of plan.
That's what you're thinking. I have like a 2-year plan.
Yeah, no, but I'm saying like
to see what the listeners are interested in. I get it.
Because I feel like the beginning is going to be rough. Because I know even me going through some of these episodes, it's a little rough.
It's understandable. Some of them are a little bit dry and a little bit long. Mm-hmm. I have attention to detail. That's a big thing for me, and I get you were poking a little bit of fun at that in one of the last episodes when I was doing a bunch of corrections on things.
Yeah,
I get it, but that's a virtue, I would say. It's a good thing to have in this line of work, to be able to say, hey, I have extreme attention to detail when it comes to studying these stories. And I consider all the perspectives and all the different explanations as I think of them, and I'm aware of the different perspectives, and I'll address them. And I have incredible systematic detail when I'm going through. And so it's just important for me personally to present myself that way to the listeners, to have that kind of integrity so they know that they're getting quality work from me. That doesn't mean I won't make mistakes, and I do make mistakes regularly. Trace makes more mistakes, but
wow, okay.
I'm kidding. Honestly, if we're talking sheer numbers, I've probably made more because I'm sure I've done much more talking for this whole 15, I think this is 15, 14, something in there, episodes that we've done.
You keep trying to steal my fish facts and stuff too, so I have to jump in. And
I haven't tried to steal your fish facts. What are you talking about? Are you referring to future events that have not yet expired?
Maybe, but creature facts too.
Well, if you want
the Icarus thing, I remember that.
That's fair. Well, if you want to try to transcend time here, like Trace has transcended time somehow, shoot us an email at musings@gmail.com. Participate in this conversation with us, whether you're listening above the earth, below the earth, or on the earth. We invite you to quantumly transcend time, and have a good night.
Doodles.